Hey, welcome back. So far, we've created wallet objects and transaction objects in the cryptocurrency. Now we're going to directly tie the two concepts together even more. We're going to give the wallet the ability to create its own transaction objects. So to do this, we're going to define a new createTransaction method in the wallet class. Therefore, let's open the wallet index.test.js file. Cool. When we create the transaction with the wallet class, it will conveniently specify the own local wallet instance as the sender wallet. So let's describe a new group of tests for this createTransaction method. So we have createTransaction and then our familiar describe callback. Now to create a transaction, you need a sender wallet, an amount, and a recipient. Conveniently, the sender wallet in this case is going to be the wallet object that has the createTransaction method. Overall, we have two test cases to cover. Consider the case where the designated amount for the transaction exceeds the wallet balance. Now, should we allow the transaction object to be created from the wallet? Probably not. So let's describe this case, and the amount exceeds the balance. So this is a situation where the designated amount for createTransaction exceeds the wallet balance. But then we also have the case where the amount is valid. So this is the opposite case, in which case we want to go through with the transaction. Well, at least for now, until we think of something else, which would make sure that we don't want to do the transaction. Okay, let's add a test for the invalid case. In this case, we're going to expect our createTransaction method to not complete its functionality. Previously, in our code, we prevented functionality from happening due to invalid conditions before. This can be seen most immediately in the replace chain function of the blockchain/index.js file. So you see, if a rule is broken, it returns out of the function early. And on top of that, it also logs an error. For the createTransaction method of the wallet, we're going to do something similar. A more powerful way to halt execution is to throw an entire error object. So this stops the flow of the JavaScript execution and can kill the entire JavaScript program. This is definitely a more powerful way to make sure that a transaction can't be created. In this test, we're going to say that it throws an error as the result. Cool. Now, to check that the method throws an error, just gives us a nice toThrow method. And what's convenient about toThrow is that you can even check that the error contains an error message. So let's expect that if we have a callback function which fires wallet.createTransaction, that this overall is going to throw a message that says the amount exceeds balance. Cool. Notice that the actual value for createTransaction has to be a callback function to call that code. And in the context of that, we're going to expect Jest to figure out that an error was thrown with the relevant error message. Now, this createTransaction method should also have some arguments. To create a transaction with the wallet, well, we need the amount and the recipient since the wallet is already the wallet itself. So let's provide an object that has an amount as well as a recipient. For the amount, let's make it something absurd so that way the amount actually exceeds balance. And again, we can use 6 nines, so 999,999. So that way it's 999,999. Wow, that's a lot of times saying 9. And the recipient can be anyone, so how about foo recipient? Cool, so this should cover throwing an error if the createTransaction amount is bad and exceeds the balance. This brings us to the valid case. And in this case, we actually want to create an instance of the transaction object. So we'll say as a test, it creates an instance of transaction. We'll also use backtick since this is a class name and a JavaScript keyword that we've created. Cool. Now the transaction behavior is tested in its own transaction.test.js file. So a lot of the stuff like signature verification and the fact that the output map is formatted correctly as well as the input is created in there. So as long as we have an actual transaction instance, we can trust a lot of those existing tests. But on top of that, we're going to make our own tests for the behavior of wallet.createTransaction specifically. First up, we need to make sure that it matches the transaction input with the wallet itself. So the transaction input should match the wallet. And this will make sure things like the sender wallet.input public key becomes the address, as well as the signature comes from the wallet itself. Another test that we need is that it outputs the amount to the recipient. So this is going to be some logic that we pass in to the transaction class, so we need to make sure that that gets set correctly. Now, each of these tests will be interested in testing a transaction object. Likewise, the test checks that the amount is outputted to the recipient. So therefore, we need access to variables to represent each of those things. First, we have the transaction. Then we have the amount. After all, we're basing this overall test around an amount value. And then we have a recipient as well. Before each of the following tests, we're going to assign values to these. So first up, let's make the amount something valid. We can make it 50. The recipient, we're going to feature again our star of foo recipient. Here, the recipient comes back, welcome. And then finally, the transaction is the result of calling wallet.createTransaction. And as mentioned before, we have an amount as well as the recipient, and both have already been declared, so let's pass those values in to the incoming object of createTransaction. All right, very awesome. Finally, we're going to check that this resulting transaction matches all of these tests. So let's expect that transaction is indeed an instance of the transaction class. And this should be true. So we'll attach a to be true qualifier. Notice though that we have an instance on the transaction class though. So once you add that test in, make sure at the top of the file that you import the transaction class. So const transaction is the result of requiring the local transaction file. All right, once you have that requirement, head to the next test that the transaction input matches the wallet. And in this case, we're going to expect that the transaction.input.address matches the wallet's public key. So we're going to check wallet.public key and make sure that this is equal to the actual value of the transaction input.address. For the last test, we want to make sure that the output map has an amount designated for this recipient. So let's expect that if we have transaction.outputMap and we look at the recipient value, that this is equal to the amount. All right, very nice. With all of these tests down, we're free to run the test command and see them all fail. Woohoo! So make sure you have all of these, and then we're going to get to that red sea of tests. So let's open up the command line. And if you don't have the test running already, fire npm run test. Otherwise, you're going to see all of these failures. All right, awesome. So the next goal of the course is to, of course, clean this up and write the code to get these tests to pass. Now, if you're hunting for an opportunity for a challenge, then I recommend researching the throw syntax of JavaScript, so that way you can expect that it throws an error when the amount exceeds the balance. Cool. With that being said, let's get down to business and defeat these failing tests. So we have to go to the wallet/index.js file. And the first thing that we need to do is that we need to make this create transaction method. This takes in an object with a recipient as well as an amount. Cool. So as we save this should get past the errors where create transaction is not defined. But first up, we should expect that this method throws an error if the amount is too high. In other words, if this amount is greater than this .balance. Well, in this case, we're going to throw an instance of the error class in JavaScript. So that is throw new error class. And then we can pass in a message. And let's say that this amount exceeds the balance. And as short, amount exceeds balance. Now, as we save this, we get past a test where we're expecting this to throw an error. Very cool. Now, the next one is to actually return an instance of the transaction class. And to do that, well, we need access to the transaction class to begin with. So at the top of the file, let's get access to the transaction class by requiring the local transaction file. Cool. And the result of create transaction is going to be to return an instance of this transaction class. So this should get past the error where we're expecting the result to be an instance of the transaction. Finally, we need to make sure that the actual sender wallet, recipient, and amount is specified when we create this transaction. So we have the sender wallet, the recipient, and the amount. And the recipient and the amount come into the create transaction method itself. But as for the sender wallet, we want to designate that the sender wallet is the local wallet instance. And to refer to that, we can use the this object, which represents the overall instance itself. Now, as we save, you'll notice that the test suite is fully green. All right, cool. There's balance once again in the force. We got past test cases where it matches the transaction input with the wallet and it outputs the amount to the recipient. Awesome. Now, the transaction coding fun doesn't stop here though. Think about this. If a transaction for the wallet already exists in the system, does it make sense to generate an entirely new transaction if the wallet wants to send more currency to the same or another recipient? Well, why not just take advantage of the existing transaction and specify another amount for the new or same recipient in the existing transaction's output map? Then the input can be re-signed, and therefore we can take advantage of the existing transaction object. So, as the next bit, let's make these transaction objects updatable.